Okay, another problem. Still working on midterm number 3 review sheet, and this is problem number 10. And this one says, now we're into the probability theory. This one says, consider the experiment where you roll a fair six-sided die. Let the sample space be 1, 2, 3, 4, 5, 6, and consider these events E1, E2, E3, E4, and E5, and E6. And each one, let's see, event 1 is a 1, 2, 3, event 2 is a 4, 5, 6, event 3 is a 1, 3, 5, event 4 is a 2, 4, 6, event 5 is 4, 6, and event 6 is 1, 3. And it says to recall the formula for disjoint events. So I can calculate the probability of a union of two different events as just the sum of the two probabilities as long as they're disjoint. And that means they don't have any elements in common, and that means I'm not double counting any elements when I add their probabilities. Okay? And so I'm going to calculate the probability of occurrence of events E2, 3, 4, and 5. Because it's a fair six-sided die, I have equal probable events in space, in this sample space, and I can write that the probability of event E2 is the size of the event E2 all over the size of the sample space. And the size of the sample space is 6, and E2 is that I roll a 4 or a 5 or a 6, and so I write 3, and so I get a 1/2 or 50% probability, or 0.5. Probability of event E3, similarly, is the size of its set all over S, and E3 is again 36.5. Probability of event E4. E4 has size 3 also. 3, 6, or 0.5. Finally, event E5, probability of event E5 is the size of event E5 over the size of the whole set. Notice I'm writing out the formula every time, showing my work. Okay, E5 though now has only 2 elements in it, so we have a 1/3 probability here. Okay, so that's part A. Looks like I might be running out of room. Write out the elements of the event E3 union E5. Okay, E3 union E5. Well, E3 is 1, 3, 5. Union E5 is 4 and 6. Okay, and this is 1, 3, 4, 5, 6. And let's see. Calculate the probability of this event. Probability of E3 union E5 is the size of that set divided by the size of the sample space, which is 5 over 6. Okay, we'll leave it as a fraction. I've got 5 elements in there. Notice 2 is missing. Okay, part C asks, does the disjoint event formula apply to calculation of E3 union E5? Yeah, it does, because E3 and E5 were disjoint. E3 had 1, 3, 5, and E5 had 4 and 6. They're disjoint sets. And so let's take the probability of E3 and add it to the probability of E5, and I'll bet we get 5/6, which we arrived at by actually taking the union and then calculating. Probability of E3 is 0.5. Probability of E5 is 1/3. So 1/2 plus 1/3 is 3/6 plus 2/6, which is 5/6. So the formula does work in that case. And I think I'll use a different piece of paper here and carry on with problem. Well, maybe I'll just use the back of the previous page. So that was parts B and C. Part D says, does the disjoint formula apply to the calculation of EU union E4? E2 union E4 is, let me write them all out. E2 is 4, 5, 6. Union E4, which is 2, 4, 6. And I can see these are not disjoint because 4 and 6 are in both of them. 2, 4, 5, 6. Okay. If so, show that the formula works. If not, show that the formula does not work. Okay, well, E2 intersection E4 is equal to 4 and 6, which is not equal to the empty set. So E2 and E4 are not disjoint. Okay, I'm going to run out of paper here. So the formula does not apply. And what I can write then is that the probability of E2 union E4 is the size of E2 union E4 divided by the size of the sample space. And this set, E2 union E4, had size 4. So we had a probability of 2/3 there. Now let's show that the formula doesn't work and calculate P of E2 plus P of E4. And the probability of E2 was 1/2, and the probability of E4 was also 1/2. And that sure does not equal 2/3. Okay? And so that demonstrates that the this sum rule, or the probability for disjoint events rule, does not work when they're not disjoint. Okay? Here we double counted the 4 and the 6, and that caused our probability to be way too high. Okay? So that's problem 10.